Okay. Of course.
Mr. Mercado, please call 502.
Yo,
Mercado, please call
this right here
502. Thank you.
is telling us, it's just a fancy way of saying that h prime of x is f of x, which is this. Okay? If you know the derivative and you know 1 point, you can write a function for that with an integral in it. That's what we've been doing in class. It's this. H of x is equal to 13 plus the integral from 5 to x of 3t squared plus 4t dt. That's our rule. Now, it says do it without having an integral in it. So that's not that can't be the final answer. Okay? So all we got to do is integrate that thing and simplify it down. Alternatively, we could have just integrated it with a plus c thing and found c. Okay? But both give you the same thing. It doesn't matter which one you do. If it's a calculator question, you should do this one, because then you can use the calculator to do the integral. Okay? But this is going to be 13 plus, it's going to be t cubed plus 2t squared from 5 to x, which we're going to plug in. X cubed plus 2x squared minus, then we got to plug in 5. So that's x, plug in 5. It's 125 plus 50, that's 175. Okay? Which is x cubed plus 2x squared, whoops, not equals, minus 162. Does it make sense that h, right now, that we just found it, if I derive it, do I get 3x squared plus 4x? I sure do, that works out. And if I plug in 5, do I get 13? You sure do. So it works. Okay, it's the only function that fits that. Only one in the world, and we found it. Okay? Now we want to know what's the maximum value of f, or h. If you had a calculator, we just graph the dumb thing and see it. Okay? But in general, the way you find the maximum, okay, is you derive it and find where it's 0. 3x squared plus 4x, that's the derivative, has to be 0. We okay with that? Equals. Turns out that you can factor out a x, leaving you with 3x plus 4 equals 0. Cool. What are the answers to that? 0, negative 4/3. What do we need to do now? Find the max. Plug in 0, plug in negative 4/3, plug in negative 5, and plug in 3. Okay? That's a little bit much, but we can do it. It's not really too bad, I guess. H of 0 is easy. It's negative 162. Cool. H of negative 4/3 is a pain in the butt, but we can do it, I think, right? Negative 4/3 cubed, what's that? Your favorite number, negative 64/27. Perfect. Plus 2 times negative 4/3 squared. That's 16/9. We okay with this? Minus 162. Okay? This is a pain in the butt. I'm not going to make you do this without a calculator. Yeah, okay? So we can just throw this into a calculator. If you didn't want to do, if you had to do it without a calculator, you got a common denominator, but 27ths and 162, it's going to be too much. I don't feel like doing that crap. This is when I was younger and I had more energy to do this stuff, you know? It's 32 divided by 9 minus 162, and I just did this in my head, even though you hear these calculator buttons. It happens to be negative 4,342 over 27, which is negative 160.8148. Okay? So, don't let the arithmetic here mess with you. The process is what's going on, okay? Found the critical values, we plug them in, we plug in the endpoints. So we also got to plug in h of stupid negative 5 and h of 3. H of 3 is 27 plus 18, what is that? 45? 45. Took away 162, what's that? Negative 117. Sounds good? If you plug in negative 5, that's negative 125. Hope I'm not messing this up. Plus 50 minus 162, which is negative 75 minus 162, which is what? Negative 2. Oh my God, I was not even thinking. I was waiting for you to answer this question. Negative 125, take away 162. So again, if you're watching this and you're studying for this test, don't worry about the dumb arithmetic. It's 237. Okay? It says find the minimum value, or it says find the maximum value, which is h of 3 is the maximum value. And you could write a little sentence here. It doesn't say to write your... Okay. What's up? Huh? No. They're all negative. They're negative. Cool. So you could write like the maximum is negative 117 at x equals 3. Easy enough? Great. Let's keep going. I'm going to erase all this junk. So, again, the hard part of that was all that dumb arithmetic. The process is what matters, okay? Okay. Given this thing, find f prime of x, our rule is this. You plug in the top thing, that gives you secant of x squared, times the derivative of what you plugged in, that's just 1. Minus plug in the bottom thing, that's 2, times the derivative of what you plugged in, that's 0. You just get this. That's the answer. That's f prime of x. Okay? F prime of x for this next one, again, since we're going from a constant to x, you're just plugging in x. Okay? And 9 is the same stupid thing. The derivative of that is ln of x squared plus x. How nice is that? We're deriving things left and right here. We're going like a machine. Yes? Yeah, the only one you have to worry about, like, really what you're plugging in is 10. Yeah, 10 has, like, weird things you're plugging in. If you're going from a constant to x, and it's an integral, you're deriving it, the derivative is just the inside thing with an x plugged in. Okay? Now, this one we got to worry about. So, if you want to find g prime of x here, it's sine, plug in x squared, so it's root of x squared, that's just the absolute value of x. Okay? Again, not a crazy thing, but that's what square root of x squared is. Times the derivative of what we plugged in, minus plug in 2x times the derivative of what we plugged in. Cool? It's important to note here, you're not deriving like the inside of that sign, you're deriving what you plugged in. Okay, hello there. Yeah, sure, why not? If we had to do this question without a calculator, which again, you're going to have a calculator, but if you had to do this without a calculator, we'd have to know what this graph looks like a little bit, like where it's positive and negative, okay? So you can do one of two things. You can find what makes it 0. We can take out an x. That leaves us with 2x minus 1. What makes that 0? 0 and 1/2. We can check those intervals. Positive, negative, positive. Okay? So if I want to find the area, how many intervals do I have to do? Well, it looks like we should do 3, but we're starting at 0, remember? So back here doesn't matter. We have to do 2 integrals. 1 from 0 to 1/2, that's going to be a negative number. Okay? And then 1 from 1/2 to 4. That's going to be a positive number. We have to turn the negative number positive because it asks for area specifically. Okay? If it didn't ask for area, I would just integrate from 0 to 4 normal. Cool? So it'll look like this. Integral from 0 to 1/2. We're going to change the sign of it. Of 2x squared minus x dx plus the integral from 1/2 to 4 of 2x squared minus x dx. Handle that? And again, if you have a calculator, you would just do this. This is the same thing. Absolute value of 2x squared minus x dx. You're going to get the same answer if you do either one of those. Or, I mean, you have to actually do this integral. Okay? But since we're kind of crunched for time here, I'm going to hope that you guys can integrate this and plug in. Cool? But you're also going to have a calculator, so you can just do it through the calculator at this point. Make sense? Okay? And just since we're checking, let's just go ahead and write what the answer is here. What are we integrating here? The absolute value of 2x squared minus x, right? Comma x, comma 0, comma 4. Kaboom. If you did it without a calculator, you would get 139 fourths, which is 34.75. But this right here is a totally fine answer. If you didn't have a calculator, you get that, okay? What's up? Yeah, sure. Go ahead. Join the party.
So if the question says that a wind is blowing from the south,
Yeah, that means it's blowing north.
yeah, but how should I draw it straight with the
Yeah,
that?
yeah.
And then the
But if you're trying to draw a triangle, attach it to the end of the other vector.
yeah, so this is that.
Yeah. So draw it straight up from the end of that.
I don't do the triangle.
Oh, or find components. Okay.
Like, wait. So when I do this, I should just do this as 90 degrees, right?
Yes. Okay. This is a rate in, rate out. These are very simple functions because it's supposed to be without a calculator, okay? When I test with a calculator, there'll be weird functions. All right, but the idea is the same. I'm giving you rate in, rate out. I'm telling you at time 4, there's 500 gallons in the tank, okay? And I'm telling you water's pumped in for the first 8 hours. So that means that if we were going to do this, the amount function is going to be the amount of water in the tank at time t, and what's it going to equal? That's the derivative. That's the rate of change. The amount's going to be the amount we know. We know there are 500 gallons at 4. Cool. And what's the rate in? This is pumped into. F is rate in. So it's F of x minus g of x dx. You could do that right now if you want. If one of them was a piecewise function, it makes sense to split them up because the piecewise is going to change. Okay? Since they're not piecewise, I'll just keep them together. But like the snow one we did or the water tank one, it makes sense to break that apart so you can handle the piecewise ones separately. Okay, so when is the amount of water in the tank decreasing? Increasing? When the derivative, which is f of t minus g of t. Do you see how we're using the rule we just did to find the derivatives of integrals? I plugged in t times 1 minus plug in 4 times 0, basically. That's why that's a derivative, okay? We need that to be, well, greater than 0, right? Okay, if we had a calculator, I would just graph them and see where it's positive. Without a calculator, f minus g is 3t minus a half t. What's that, 5 halves t? I'm subtracting them, and 1 minus 8 is negative 7. I need that to be greater than 0. Okay? Again, that's just f minus g. And we can solve that. That's for t greater than, what is that, 14 fifths? And if it said explain, that's your work. I need the derivative to be positive. I got this. And we write our little answer up here. When t is greater than 14 fifths. And if it asks us to explain, which it doesn't, but if it did, you would write since f of t is greater than g of t, or you don't have to write this with that, okay, you can also write this, or where a prime of t is positive. That's the same thing. Okay, that's how we always tell where something's increasing. We find where its derivative is positive. Okay? When's the amount of water in the tank the greatest? Well, we got to find the critical values, right? So we got to find when is a prime 0. We already did that. That was 14 fifths. You're right, Riley. Which means we need to find the amount at 14 fifths. We need to find the amount at 8. And we need to find the amount right up here, but at 0. Cool? Yeah, you gotta check the endpoints and the critical values. Now, we don't have to check 14 fifths actually, right? Because it's positive after 14 fifths. Like if we had a number line for a prime of t, 8's an endpoint, 0's an endpoint, it's this. So 14 fifths is a minimum. Cool. So you don't actually have to check it, but when you explain that, you're going to say I checked basically the endpoints, and there was nowhere where a prime changed from positive to negative. So that's how we find maxes. Okay. Do you feel like you could find a of 0 and a of 8, especially with a calculator? Can you do that right here? Okay. So I'm just going to use a calculator, but I'm just doing exactly what it says on that screen. So it's 500 plus the integral of f minus g with respect to x from, what are we doing, 4 to 0. So I'm finding a of 0, and I got 508. There's 508 gallons. Okay. You okay? Cool. And find a of 8, I'm going to do the same thing. I'm going to integrate from 4 to 8. So 532. Okay? And if it said justify, because on a real AP test or on the test we're taking Monday, I'm going to actually justify this. Okay? So you're going to have to write something like this. So it's at 8, there's 532. So we're going to write the maximum amount of water in the tank is 508 gallons. Hey, what is this? There's 508 gallons at T equals, what was it? 8? Is it hours or minutes, or I don't have this in front of me? Minutes. I checked the endpoints, and there were no x values. But this is a bad question. If you see this question, there's going to be places to check other than the endpoints, okay? But there were no x values in this case where a prime of t changes from positive to negative. Cool. If there were, we would check them and say, I check the endpoints and where a prime of t changes from positive to negative. Cool? Cool. Did I say cool too much? Okay. C is, when is it the least? We're going to do exactly the same thing that we just did, except we have to add in now the amount at 14 fifths, right? So the only other thing you'd have to do here is find the amount at 14 fifths, which we do the same exact thing we've been doing. We integrate the 14 fifths, and we get 498.2. Okay, and I know I'm using a calculator, but we can actually integrate this thing if we had to, right, and get values out of this. Boom, I just don't feel like doing it. No, you're going to have a calculator. Okay. It's possible, like if you take the AP test or you see a multiple choice question, it could be like this, and you have to integrate by hand. But for the most part, these are on the calculator section. Okay? So you write a sentence for this too. Same exact thing. Let's come over here and change it. This is so easy. The minimum amount of water in the tank is, I forget already, 492? 498.2 gallons at T equals 14 fifths minutes. I checked the endpoints, and where a prime of T changes from negative to positive. Okay, because we look for a min, so we're looking for what changes negative to positive. The derivative changes from negative to positive. Notice I'm not saying it, I'm saying a prime of t. Okay? Alright. What's the next one here? If it costs $1.05 per gallon, how much does it cost to pump the water into the tank? What do we need to know? Yeah, we need the cost from 0 to 8, but we need to know how much water went in. Okay, it doesn't matter how much came out. Okay, they're saying it's $1.05 per gallon. They want to know how much does it cost to pump that water into that. So we don't need f of t, we need the integral of f of t from 0 to 8. But that's going to tell me how many gallons. I need to multiply it by 1.05. What's up, Sabina? What do you mean? Airspeed just means what the plane's trying to do. Ground speed is what's the wind. Alright, well then don't worry about that problem now. We'll go over it. So the answer to this, if you're playing along at home, which is what, 3x plus 1, comma x, comma 0, comma 8. What did you get? 109.2? $109.20. Okay. And when will the tank be empty? Means we got to find out how much. You can do this a couple different ways, right? We got to find how much water went in, the same amount has to come out, plus how much was in there already. Cool. But I think the easiest way is to take how much there was at the end, which was 532 gallons. Okay, remember it said water's only pumped in from 0 to 8. Okay, water's still being taken out. So I need the amount of water that's taken out to be 532 gallons. Okay? Well, and that's after 8, okay? So the amount that's taken out is just this. I need that to equal 532 gallons. Okay? The only way we can answer that, if there's, again, we want to solve for t, we're looking for this, you have to be able to do this integral. Okay, if you can't do the integral, you can't solve for t. But since g is just this dumb function, 1/2 t plus 8, get out of here. We can actually integrate it. It's 1/4 x squared plus 8x from 8 to t. And that's just 1/4 t squared plus 8t minus some junk. What do you mean plug 8 in that? 64 before 16 plus 64? 80? Did anybody get 80?
Wait, is that
What? No, we're going from 8 to t. I integrated it, right? I plugged in t. Then you plug in 8. But it's 16. Yeah, 16 plus 64. I think that's right. Yeah, you subtracted it.
Oh, that's a 2, sorry. This way.
Oh, where?
The T to the T2.
T, oh, here? Yeah, it's a 2. But we need this to be 532. We could solve that without a calculator, but I really don't want to. So, I'm going to graph this dumb thing. Plus 8x minus, what's it going to be? Well, 80 and 532. Dope. You kicking me out? This is my room, Dungy.
Well, I keep telling you to have it somewhere else. He said, but it's easier for me.
If what?
You're always like, oh, this is the best place to have it, and then you lock it out of the room.
And that's what I sound like?
Yeah.
That's my voice?
All the time.
That is a very good impersonation. I'm recording this, by the way. I'll put this on YouTube. So it's good.
It's hilarious.
I'm not seeing an answer here. Where's this graph? There it is. I'm gonna get out of your way in 1 second. 0. I don't know. Where my graph from? 15.
Scared not to. She should come in.
She was scared to come in.
Because she thought I had
She's
it.
probably scared of how ugly these kids are. She wouldn't be in there.
All the time, you have to take it. You know what?
No, we
Oh, it's just 36.
My team was 2 ugly.
Wait, what?
My team was 2.
Okay.
Teams 1 through 5, and then
That's that. We didn't get through the rest of it, but that's a pretty good chunk.